Okay, now I'll start weighing mass number 1, which is the mass of the empty beaker. Okay, this is the empty beaker and the dry beaker. Okay, take the mass. I know that the reading of the balance is always making problems, but take the reading if the last or the last two decimal places are moving, it doesn't matter. Okay, now you can take it. This is the mass, record it. After that, I'll weigh approximately 1 gram. Now take the reading as it is. Approximately, as I said, doesn't mean that the accuracy is not important. No, the accuracy is very important, but I will not spend a long time to take one with 5 decimal places. So I'll take around 1 gram, but take the reading as it will appear right now. Okay. Here is the hydrate, by the way. Look, it's solid. It's a white solid. It contains water, but solid. Why? Because the combination, as we said, between water and the hydrous is chemical. Okay, this is the hydrate, sodium carbonate. This is, by the way, this is sodium carbonate hydrate. Okay. Maybe I need a little bit more, so I'll add a little bit of the sodium carbonate. I'll make some. Just to obey the procedure in your lab manual, it states that we should take 1 gram. Yeah, now it's okay. It's very, very close to 1 gram. Take this reading, 0.972. I'll wait for a few seconds. Yes, you can take it. This is the mass of hydrate. Now, I'll put the hydrate inside the beaker. Okay, now we'll take the reading of the beaker and the hydrate. Take the reading once it's stable. Yeah, you can take it now. Record this reading in your lab manual. Okay, what I am gonna do now, I'll go to the Bunsen burner and I'll heat everything. Then I'll come back. During that, I'll explain all steps. The next step is heating using the Bunsen burner. I'll start heating not more than 40-45 seconds. Why? Again, because this temperature is very high if you compare it with the melting point of the anhydrous salt. So I don't want the anhydrous salt to be evaporated. Okay? I want only to evaporate water. So I do like this, slowly and gradually. As you can see, nothing is observed. So this is why I depend on mass to tell when shall I stop this step. Nothing is observed. Water is colorless. Okay, I heat. Yeah, that's it. Okay. Now what I'll do, I'll allow it to cool slowly. Then I'll wait. I'll go back when it's cold. Okay. Now the beaker is cold enough to catch it. I will record its mass. Take this reading, but as I said, we repeat this heating process until we got a constant mass. The previous mass, as I remember, it was 32.32, something like this. So as you can see now, it's 32.21, which means some of water evaporated, but I cannot judge whether the whole amount evaporated or not. So I'll take it and I will reheat for another tray. Okay, shabab, this is the second heating step. I will repeat heating for 30-40 seconds. Then I reweigh the beaker again. There is no other way, by the way. No other way to judge when the water will evaporate completely. Ten seconds more. Yeah, let's go and weigh it, but I will come back when it's cold. Okay, I record the mass now. It's cold. I think the previous mass is It was 32.22, 23, something like this. You can see now it's still decreasing. So what I'll do, I will heat for the third trial. Now what I'll do, I'll stop this video and I'll come back when the mass is constant, and I'll inform you how many trials I needed until I got this constant mass. Okay, shabab, this is the 5th heating trial, okay, and the mass now is constant. I'll show you the mass now. Take the reading, please. Yeah. Yes, you can take it. Now everything is ready. We can easily complete our experiment. All required data are available now. We can determine the mass of anhydrous salt by subtracting the mass, this mass, minus the mass of the empty beaker that we got in the first step. And we can determine the mass of water evaporated by subtracting this mass, or the initial mass, the mass of the beaker plus hydrate, the first mass, which was 32 point something, minus this mass, okay? Or by subtracting the total mass of the hydrate, which was 0.97 something, minus the mass of the anhydrous salt, okay? You can do whatever you want. And after that, we can complete the calculation easily, because to complete the calculation, the required three masses are available now. Okay, thank you very much, and I'll explain the details and I'll answer any question related to this experiment during the lab time. Thank you very much.